Hi students, I'll be handling chemistry for you today. Now, chemistry is a very fun subject. You know, it's like a mystery. The name itself is having chemistry, which is a mystery. So it's like unraveling a mystery. You all have read crime novels or detective stories. It's just like that. Understand it to be like that. You're unraveling what will come after the reaction. If hydrogen and oxygen mix together, what does it form? What do you get? So it's like a mystery. It is very fun to learn. Now, before I go into chemistry, chemistry is a branch of science. What does science do? What is the aim of science? Now, science is it's a human effort to understand the problems that are occurring in the surroundings, understand the nature, understand the problems, and it's an effort to solve it. That's what does. Now, science is classified into many other branches. It's just for the sake of convenience, uh, because different problems or different you know studies can be given to different people. So it can be the work can be divided. So that's why science, if you see, it has been divided into many branches. Like, you have pure science or natural science. Okay, then you have social science. I'm sorry, the board is very small, so you'll have to bear with me in this. Then you have formal science. Then you have applied science. Okay, now this is what you will be learning till your 12th standard. This is what you will be learning after it, because this contains engineering and applied science, applied physics, then your biomedical field. Everything comes under applied science. What you do is, what you learn till 12th from these things, it will be applied over there. That is applied science. Now, what is pure science or natural science? Pure science or natural science is actually you're creating the foundation. The foundation is what is pure science or applied science. Now, it itself has been divided into three branches. Not three, many branches are there. I'll be talking about that. Now, social science is the study of human nature or human behavior. Okay, and formal science, it contains maths, your logic, your maths. These are the tools which are required to understand the pure sciences. Uh, to understand pure science, you require formal science. Okay, so I'll just briefly summarize. Social science is a study of human nature, human behavior. Formal science is the tool which contains mathematics and logic and all. It is utilized in pure science to understand the nature, and it is applied in the applied science to develop new inventions, to develop new products and all. This is what is done. Now, pure science, I'll just show the classification of pure science. We must know how we came to chemistry, right? Just directly digging into chemistry is not the way that I would prefer. So first of all, pure science, it has been classified into life science and physical science. Now, life science, as the name suggests, it is biology. It's the study of living system or living things. Now, here you're learning about non-living objects or non-living systems. In this, the classification comes. Shall I erase this? Due to lack of time, I'm rushing through these subjects and it's not very important. That's why I'm just rushing through this. If you have any doubts, you can ask. Now, physical science, it has been, it has some categories like physics, then you have chemistry, then you have earth science, which we call as geography. Sorry. And you have many others out there, oceanology, then meteorology, astronomy, you name it, it's there. Now, in this, physics is the study of matter and the motion of matter. Matter, its interaction, the motion of matter, all these things comes under physics. Now, chemistry, before we come to chemistry, earth science, you know what is oceanology, these all things are not important. Now, physics is study of matter and its motion. Now, chemistry, what is chemistry? I'm rushing through this. I'm telling again, I'm rushing because of the lack of time. Now, chemistry is what does a chemist learn about? Chemistry is the study of molecules and its transformations. That is, you're learning about the matter not from the outside but from the inside. Inside the matter, what is happening? Now, inside the matter, its composition, the composition of the matter, the structure of the matter, or the properties of the matter. All these things are it pique the interest of a chemist. So, chemist is his main concentration will be on these things. To learn about these things, you need to understand what is happening inside. And what is inside a matter? Inside a matter, atoms and molecules are there. These are the things inside. As Roald Hoffman once said, chemistry is the study of not hundreds of molecules that are available in the hundreds of elements that are available in the nature, but of the infinite varieties of molecules that you can build from these elements. So at present, you know that there are around 118 elements, but in your textbooks and all, you will find it maybe 114, because new 4 elements have been introduced to the periodic table. Okay, you will be learning about the periodic table and all those things in the coming lectures. Shall I erase this? So, you see that matter has so many elements. Now, you can see that the new elements that are introduced, the last of them are, one is, tennessine, which has an atomic number of 117, and then you have oganesson, which has an atomic number of 118. See, some people may not be able to remember these names, so and easy to remember names are also available. It is called as nuncium. Obviously, 1 septium. That's it. Similarly, you have oganesson. It is also known by the name onan octium. That is 118. It's like Hindi. In Hindi, you have the number system. People are not able to remember the numbers. For example, you have 91. People in Hindi, it is known as Ikyanabbe, right? But in villages and all, if you go and ask the people, they'll say Nabbe per ek. It's not, they'll not say Ikyanabbe, because they don't remember that name. So they'll say Nabbe per ek. In the same way, unun septium. Anyway, these things are not that important. Right. So now you have seen that chemistry is the study of matter. Now you cannot say that all the sciences are independent of each other. You can see that if you are learning physics and if you are learning chemistry, there will be some portion which will be coming under physics as well as chemistry. For example, thermodynamics. Thermodynamics comes under physics as well as chemistry, right? Because thermodynamics is dealing with the heat formation, and during many chemical reactions, heat is produced, and so such things are also there. For example, biology. If you are learning biology, it cannot also be taken as independent. There will be relation between chemistry and biology. For example, DNA. If you're learning about DNA, it comes under chemistry as well as in biology. You'll have a chapter in your 12th standard, if I remember it right, on DNA, right? So these are the way the science is related to each other. Now, when you learn science like physics, chemistry, biology, etc., you acquire the knowledge for that. Now, if you are able to, apply that, apply in real life, then you can become a lab technician. But if you are able to, if you know mathematics along with that, then you will be able to not only learn the concepts in physics and chemistry, but also improve upon that using the mathematical tool. So then you can, if you know all these three things, you will become an engineer. If you know maths and if you know the theory, you are able to develop certain equations and all, just that, but you don't know how to apply it in the real life, then you can become a scientist. This is how the future stays. If you know only these two things, there's nothing over there. This is how the Venn diagram goes. Okay. Now, see, nature of matter. Now, matter can be classified into three main categories. That is, matter exists as a solid or liquid or gaseous state. These are the states that you find. Now you already know how to convert from this to this. If you heat a solid, you'll get a liquid. If you heat a liquid, you'll get a gas, and it's reversible. If you cool a gas, you'll get a liquid. You'll get the liquid form, and if you cool the liquid, you'll get it in the solid form. Now, solid form, the atoms are very closely packed together, and it has what do you call the atom interatomic intermolecular attraction, and because of that, solid has a definite volume and definite shape. But liquid, the intermolecular attraction has reduced because their heat energy has been applied to it and has been input to it. So because of that, liquid has a definite volume but not definite shape. It acquires the shape of the container in which it has been put. Similarly, what about gas? Gas does not have a definite volume and does not have a definite shape. It completely occupies the container in which it has been placed. So the volume of the gas is the volume of the container, and the shape of the gas, that entire gas is the shape of the container. So that's about nature of matter. Now you can see the matter existing in the world, it can be classified into two categories, mainly based on the constituents. If it is having a single element, that is, if it is having a monoatomic or a diatomic, single, it has a uniform composition throughout, uniform and definite composition. If it is having, that is called a pure substance. But you have certain mixtures also. For example, salt. Sorry, I'm going to use that example over there. So salt is also an example. Sugar. Sugar is an example of pure water, pure substance. Water is an example of pure substance. What is a mixture then? Mixture, you can take an example of sugar plus water. If you mix sugar and water, you get a mixture. If you have these separately, that is called a pure substance. Okay. Now, mixtures can also be divided into two categories: homogeneous and heterogeneous. right? Now homogeneous, as the name suggests, throughout the composition of the elements that is present inside will be same. For example, if you take a portion at the top, the composition will be same. If you take a portion from the bottom, the composition will be same. The example of sugar and water is a very good example for this homogeneous mixture, because if you mix the sugar completely in water, whichever part of that container you drink from, it will be very sweet, right? And the sweetness will be same whichever part of the container you drink from. So that means that it is a homogeneous mixture. There are many other homogeneous mixtures. For example, air is a homogeneous mixture of the gases it contains oxygen, it contains many inert gases, it contains nitrogen, many gases are there. All these things are in a uniform composition. The composition is same, right? Now, what is then heterogeneous? Heterogeneous is in which the composition is not same. For example, this same sugar and water can be taken. If you put sugar in water and if you don't stir it properly, what happens is at the bottom you can see that the sugar has settled. So the composition of sugar to water at the bottom is not same as that at the top. Another example, if you want, you can take an adulterated rice packet. You have a rice packet, in that some notorious people have put stones or some dust particles, so that the weight of the packet is increased, and it is adulterated. So you can see that the stones lie at certain portion. So the amount of stone at a certain portion will be more than the amount of stone in other portions. So that is a heterogeneous mixture.